Welcome back everyone. Today we learn about mole concept. Let's explain the basic terms related to the mole. Relative atomic mass of an element is the average mass of an atom in a normal isotopic mixture of the element when compared with 1/12 of an atom of carbon-12. And its symbol is Ar. Here is an example of calculation of relative atomic mass. Given the data regarding neon as seen, how will we calculate the Ar? We take the percentage abundance of each isotope multiplied by their respective MR, and eventually we will have a value of approximately 20. Explain why the relative atomic mass of chlorine is 35.5 given the following data. It is because by taking the relative abundance of each element multiplied by their molar mass, it would give 35.5 as seen in the calculations. Relative molecular mass of a molecule is the sum of the relative masses of all the atoms in the molecule. Its symbol is Mr and it has no unit. Molar mass is the mass of 1 mole of any substance measured in grams. Its unit is grams, kilograms, or tons. Now we look at HCl. The molar mass of HCl is 35.5 plus 1, which is 36.5 g. Whereas the relative molecular mass of chlorine molecule is 35.5 times 2, which is 71. Therefore, for 1 mole of substance, its molar mass is equal to its Mr in grams. Determine the Mr of these compounds. For ammonia, its Mr will be 17. For methane, its Mr will be 16. For chlorine, its Mr will be 71. For hydrogen chloride, as previously discussed, its Mr will be 36.5. And lastly for water, its Mr will be 18. 1 mole of atoms of an element is the amount that contains the same number of particles as there are in exactly 12 grams of carbon. 1 mole is 6.02 times 10 to the power of 23 and is also termed as the Avogadro constant. 6 times 10 to the power of 23 is determined from knowing that 6 times 10 to the power of 23 carbon-12 atoms weighs exactly 12 grams, and therefore the carbon-12 atom becomes a reference point. The number of moles of a substance is equal to the number of particles divided by Avogadro's constant. The number of moles of a substance is equal to mass in grams divided by its molar mass. Here is the calculation template, where the number of atoms can be represented in moles as well as mass in grams. Mole exercise 1. How many moles of oxygen atoms is that? As seen in the calculations below, the number of moles of oxygen atoms will be 4 moles. What is the mass of that amount of oxygen molecules? It will be equals to 64 grams as seen in the calculations below. For question 2, given that the mass of chlorine gas is 142 grams, determine the number of moles of chlorine molecules. Taking 142 divided by the Mr of chlorine, we will end up with the number of moles of chlorine molecules as 2. Let's now determine the number of chlorine atoms. And we calculate that by taking 2 moles times 12 times 10 to the power of 23, and for the number of chlorine molecules it will just be 2 times 6 times 10 to the power of 23. Let's look at question 3. Given that the mass of carbon dioxide is 88 grams, determine the number of moles of carbon dioxide. As seen in the calculation below, the number of moles is 2. Determine the number of carbon atoms. Take the number of moles multiplied by Avogadro's constant, and the answer is as seen. Here is some additional information, where the instrument used to examine the relative abundance of the molecule is known as the mass spectrometer. Given the graph below of the relative abundance of different bromine isotopes, calculate the Ar. Now let's do some mass calculation. In the first case, given that the mass of copper sulfate is 48 G, how will we calculate the mass of copper? We take the mR of copper divided by the mR of copper sulfate times the mass of copper sulfate. For the second case, given that the mass of hydrated copper sulfate is 50 G, how do we calculate the mass of water in it? We take 9 divided by 25 times 50 G and we will find the mass of water. The third case we are looking at is how many grams of carbon dioxide will be produced when 12 grams of carbon completely burns with the 32 grams of oxygen. The mass of carbon dioxide will hence be 44 G. The last case we will be looking at is when 16 grams of carbon burns with 32 grams of oxygen gas. Which is the reactant that will be used up completely and which is the reactant that will be left as excess after the chemical reactions? The answer will be that oxygen gas is completely used up, and that carbon is in excess and there will also be 4 grams left over. Let's look at case 5. Calculate the mass of oxygen in 90 grams of water. We first find the number of moles of water and multiply it with the mR of oxygen to determine the answer. Empirical formula is the formula for a compound showing the simplest ratio of the atoms present. Molecular formula represents the number and types of atoms that are chemically combined together to form the molecule of a chemical compound. Let's look at an example of ethanoic acid. The molecular formula for ethanoic acid is C2H4O2 and the ratio of C to H2O is 2:4:2 and the empirical formula for ethanoic acid will hence be CH2O. To find the empirical formula, we start with the breakdown on the percentage of the mass composition of the constituent atom. An example is listed below where the compound is made up of 29.4% of calcium, 23.5% of sulfur, and 47.1% of O in terms of mass. We will find the mole ratio of calcium to sulfur to oxygen and it will be 1:1:4 and hence the empirical formula is CaSO4. Let's take a look at another question, and given that a hydrocarbon is made up of 85.5% of carbon in terms of mass, and what is the molecular formula of the compound given that the mR is 56? We will solve that the mole ratio of C is to H is 1:2 and hence the empirical formula will be solved to be CH2. The second question is that given that compound X is made up of 64% nitrogen and 36% oxygen in terms of mass, and the mR of X is 44, what is the empirical formula of X? By taking the mole ratio of nitrogen to oxygen, it is 2:1. And therefore the empirical and molecular formula is N2O. Another example is that of compound Y, which is also made up of nitrogen and oxygen, and is made up of 30% nitrogen in terms of mass. What is the empirical formula? We similarly take the mole ratio of nitrogen to oxygen, and it is 1:2 and therefore the empirical and molecular formula will be NO2. Given the diagram below, determine the empirical and molecular formula. The answer is as seen below. Stoichiometry Revision. The first question is what is the number of moles of 50 G of calcium? The answer is 50/40. Next, what is the number of moles of 120 G of water? The answer is 120/18. Lastly, what is the number of moles of 51 G of ammonia gas? The answer is 51/17. The second question is what is the number of moles of 56 grams of nitrogen gas? The answer is 56/28. What is the number of nitrogen molecules? The answer is as seen. What is the number of nitrogen atoms? It will be 24 times 10 to the power of 23. What is the AR of carbon-12? The answer is 12. What is the mass of one carbon-12 atom? It will be 12 divided by 6 times 10 to the power of 23. What is the MR of glucose? It will be 180. What is the molar mass of glucose? It will be 180 grams. What is the percentage of nitrogen by mass in this compound? It will be 28 divided by 60 times 100%. Lastly, what is the percentage of nitrogen by mass in ammonia? It will be 14 divided by 17 times 100%. The units for solids in stoichiometry has a symbol S, and mass will be in grams. And it is equal to the number of moles times mR. The symbol for liquid is L and the units for the mass will be grams and the units for its volume is dm cube. The units for aqueous in stoichiometry has a symbol of AQ, and the concentration has a symbol of mol per dm cube, and the volume is in dm cube. Molar volume is the volume occupied by 1 mole of any gaseous substance. The volume of a gas is 24 dm cube at 25 degrees and 1 atmospheric pressure, also known as RTP. Avogadro's law states that equal volume of gases contain the same number of molecules under the same temperature and pressure. The bulk of space in a gas is empty and the actual volume taken up by gas molecules are negligible. Given 1 mole of oxygen and 1 mole of carbon dioxide at RTP, what is the volume of these gases? The answer will be 48 dm cube as it is 24 times 2. And when the temperature and pressure has been changed, their volumes will change. What is the volume of 1 mole of water and 1 mole of chlorine at RTP together? Since H2O is liquid at RTP, and chlorine is a gas, the answer will be 24 dm cube instead of 48 dm cube. Let's look at the quantitative analysis method. We first look at the input, where we write the equation we are provided, pen down the data and identify the limiting reactant in the input. We then look at the output which would lead to the answer. We arrow from known data to the unknown data. We convert mass, volume, or concentration to number of moles of substances. With the known number of moles of a substance, we then convert it to mass. Let's use it in an example. With the following scenario being given, how would we solve it? We start by writing the equation. By following the steps seen, we would be able to conclude that the limiting agent is magnesium while oxygen is in excess. Hence, 1 mole of magnesium would produce 1 mole of magnesium oxide and the mass of this magnesium oxide would just be 1 times the mR of magnesium oxide. Percentage yield is with regard to the amount of product produced. In such questions, the actual mass of the product obtained would be given. The percentage yield is equal to the experimental yield of product over the maximum theoretical yield of product times 100%. Let's now look at this example where we have to determine the percentage yield of magnesium oxide. In theory, since 40 grams of magnesium oxide is supposed to be produced, the percentage yield will be 38 over 40 times 100. We now look at percentage purity, which is with regard to reactants. In these types of questions, the mass of the impure reactant would be given. Percentage purity is equal to the pure mass of the reactant divided by the mass of impure reactant times 100%. Let's now look at this example. Since in theory, 24 grams of magnesium would yield 40 grams of magnesium, the percentage purity would be 24 over 26 times 100. In conclusion, we should follow the acronym ESIDOE as writing the equation. S is writing the states, where we convert to number of moles, and always remember to work in moles. I stands for determining the limiting agents from the inputs. And lastly, O is for us to determine the ratio from the output to calculate the answer. Stoichiometry, gas and volume. What is the volume of 50 grams of helium gas in RTP? It will be 300 dm cube as seen below. What is the volume of 50 grams of hydrogen gas? Taking the mass divided by the mR times 24, we will get 600 dm cube. Finally, what is the volume of 50 g of ammonia gas? Using the same method as the previous examples, we will find it to be 70 dm cube. Look at these four options, and out of them which one would occupy the larger volume? The answer will be 4 grams of hydrogen. Given that 1 mole of steam takes up a volume of 100 centimeters cube, what is the volume of 1 mole of carbon dioxide at the same temperature and pressure? The answer will be 100 centimeters cube. What is the volume of air required for the complete combustion of 1 mole of methane given that methane burns in oxygen to form carbon dioxide and steam? Since 20% of air is oxygen, 1 mole of methane needs 2 moles of oxygen, and since 1 mole of air contains 0.2 moles of oxygen, the answer will be 240 dm cube of air. When concentration in mole per dm cube times volume, it will be equal to the number of moles. When concentration in grams per dm cube times volume, it will be equal to the number of grams, and do remember that 1 dm cube is equal to 1000 centimeters cube. Let's take a look at the equation below, and given that we start off with sodium hydroxide at 0.05 moles and hydrogen chloride at 0.025 moles, we can conclude that the limiting agent is hydrogen chloride. The amount of sodium chloride is 0.025 moles, and therefore the mass of sodium chloride is equal to 1.46 grams. Another question will be what is the concentration in mole per dm cube that will be obtained by dissolving 73 grams of hydrogen chloride in 500 centimeters cube. Since the mR of hydrogen chloride is 36.5, the number of moles of HCl is 2, and therefore the concentration will be 4 moles per dm cube. The final question we will look at is which is the limiting agent when 25 centimeters cube of 1 mole per dm cube of ammonium sulfate and 25 centimeters cube of 4 moles per dm cube of sodium hydroxide react. Doing the calculations, there will be 0.025 moles of ammonium sulfate and 0.1 mole of sodium hydroxide solution, and given that 1 mole of ammonium sulfate reacts with 2 moles of sodium hydroxide, the limiting agent will hence be ammonium sulfate. First, write the complete equation for the reaction of lead carbonate and nitric acid. The answer is as follows. With this equation, determine the amount of carbon dioxide to be produced at RTP by reacting 100 grams of lead carbonate and 50 centimeters cube of 5 moles per dm cube of nitric acid. The answer will be 0.125 times 24, which is 3 dm cube. Determine the volume of sodium hydroxide with concentration of 1 mole per dm cube that will neutralize 50 centimeters cube of 1 mole per dm cube of sulfuric acid. The answer will be 100 centimeters cube. That's all for today. Thank you for the effort to learn with me. Stay tuned for more interesting lessons. See you next time. Bye-bye.